Lovely. Welcome back, everyone. We probably have a lot of people from stage 2 now that have come over to stage 1. So if I didn't meet you before, David, I'm going to be the moderator for this evening. Now, before we begin, I just wanted to remind everyone that you can ask questions in the chat or in the Ask the ShinyConf speakers channel in the Shiny for All workspace on Slack. Now, for our keynote talk of this evening, I am very pleased to introduce Tanya Casciaroli, apologies, the CEO and founder at TCB Analytics, a data and analytics consultancy company. And today she will be discussing real-world use cases for AI in Shiny. So without further ado, over to you, Tanya.
Awesome. Thanks so much, David. And I have to show everyone I'm rocking my Shiny shirt. I'm a big fan, which you'll soon find out. So let me pull up my slides. Let me know if we're good. You can see them. Present. Yes. Okay. Looks like we're good. So first, I just wanted to thank Absalon for not only putting on this conference, just a Shiny conference on my most favorite, technology of R ever. They make a ton of packages also that we use in our day-to-day client work. So check out their repo. It's super useful. I have a few of them actually in some of my use cases I'll talk about today. Brief introduction, overview. I won't bore you with the details here, but this is what you can expect. I will be very brief on what LLMs and GPTs are. They're extremely complex and technical, but I'll give a very high-level overview and mostly focus on the use cases, as well as what I think some of the limitations are and some best practices. So my brief background, my background's in computer science and biology, formally trained. I got my start in bioinformatics, so I was analyzing gene expression data back in 2005. This was actually my first deep dive into R. I sort of just was thrown into the deep end and told to learn it as an internship, as an undergrad at Northeastern, and that was quite the experience. Learned a ton. Did a couple more healthcare, biotech-related stints, and then kind of left healthcare. Did the same type of work in telecom, identifying valuable customers, switchers, and then found my way back to healthcare at Biogen. And 2015 is actually when I started TCB Analytics. We're a Boston-based data consultancy. Still have a strong focus in healthcare, but we're sort of all over the map, as you'll see, because as you all know, data is just everywhere. This is our Chief Security Officer, Porkchop. You may see the bed behind me. He may come in at some point, so that's who he is. All right, so I want to talk briefly about just my Shiny journey in general. I recently watched Joe Chang's 2022 Posit keynote. Highly recommended watch. It's linked here. These slides will go out after. But it made me want to kind of go back to, he was talking about the past 10 years of Shiny. And I thought, let me try to find like when I first started using Shiny. And here's on the right, what you're going to see is my very first post and question in the Shiny Google group. And I don't know if everyone remembers that, but it was basically a Google group just for Shiny questions, less toxic completely than Stack Overflow. Joe and Winston were super nice. They would come in and answer questions. And if you don't know, Joe Chang, created Shiny. Winston, I think, is one of the first developers as well. But I had a very basic question here that I was almost too embarrassed to post, but everyone has to learn somewhere. Would obviously not make any of these mistakes now, but they were so nice to come in and just help people. And I think that helped them get a lot of early adopters. But what's so cool about this is 11 years ago. I could put this same exact question into ChatGPT and get maybe even a better answer. No offense, guys, but now the technology has evolved and there's better ways to do things. And so you get an instant response and you get code that works rather than, waiting for Joe and Winston to get time to, in their busy day-to-day, to answer you in a Google group. So already you can see that there's tons of time savings just with coding, and I'll get into those specifics in a minute. But I also had to dig up my first Shiny app for this talk. And I sent it to a friend. I had to host it on EC2. There was no shinyapps.io. There was no, RConnect. And I actually had to go to the Wayback Web Archives to find this because I had no screenshots of it. I sent it to a friend. He said, wow, that looks so slick. And you're going to laugh, but this is what it looked like. It's not the prettiest thing in the world, right? There's been so many packages and evolution that's happened, but this was what I used for my fantasy football draft in 2013. And I don't know if I won my league or if it was useful or not, but I felt like I was, very prepared going into my draft. There was another little high charts thing where you could compare two players if you were on the fence about, who to pick. And I just kept going with building these things. And this is also ugly as sin, but this is one of the first, table implementations, I think, for Shiny, and more, fantasy apps built in 2016. Look at the difference to 2022. And this is not because, I practiced, but this is mainly because of the community of package developers that have made this stuff so simple. This is the fresh package where you can custom theme your apps just super easily. And I was just hooked. Like, I make a Shiny app, and these are old ones too, but I feel like I make a Shiny app for just everything that I'm interested in. Cooking, I was like, let me make a recipe roamer and find related recipes from a data set. How about video games? I'm a big video game nerd. So I'll build a team comp optimizer for this video game called Overwatch. Identify the most solar productive buildings in Boston. This was actually for a hackathon. And it just keeps going. And then lots of sports stuff. So this right here is looking at baseball wind data. And this was actually, I wanted to figure out how to dynamically add an arrow over an image based on a wind direction. And I was racking my brain for like 20 minutes, Googling Stack Overflowing. I put the question in ChatGPT, and it gave me the ggplot code, and it just worked the first time. And that's when I was thoroughly amazed. So let me start with just some fun stuff before we get into the client work and more serious stuff. But this is my very first Shiny app with any kind of GPT involved. And this was just an idea I had. I thought it would be really cool. So what it is like a choose your own adventure. And it's very minimal code. My prompt was, I'm presenting about AI at the ShinyConf when a bunch of robots take over the web conference. And so it creates this prompt, or the next part of the story. It says, suddenly it was hijacked by sentient robots. They started speaking in binary and flashing neon lights. It was like a choose your own adventure story, but in real life. And then you can choose, what you want to do. And my friends and I have had a ton of fun with this. You can change the tone even to say, do this in Homer Simpson's tone or Shakespeare, and even enter your own custom action. Well, I chose, obviously, the dance off. Apparently, this is me presenting, even though we're on a web conference. The robots accepted my challenge, and surprisingly, they were actually pretty good dancers. As we boogied down, I noticed a control panel nearby. I quickly moonwalked over. This is apparently me moonwalking, and managed to shut down their system, saving the conference from their neon light madness. Who knew my dance moves would save the day? Now, this is definitely not going to happen. It's also funny that they made it an in-person conference. I don't know if, they understand. This is DALL-E image generation, by the way, if it understands, how to display a web conference just yet. So that was my very first one, built probably a year and a half ago now. And it's minimal code. I also can make the codes available on GitHub. Another fun one is actually a retrieval augmented generation example, which I will talk about in a second of what that is. But as being, as I'm a nerd gamer, I own a lot of games. I have 405 games apparently on Steam. And you can enter your own Steam 17-digit ID. It will go out and pull your game library and then feed that into GPT-4 and say, I'm in the mood, for example, for a happy and vibrant casual game with a short campaign. So it looks through the data you sent it. Again, you'll understand RAG in a minute if you don't already, and then provides you a recommendation. Okay, so that was kind of the fun examples and my part of my Shiny journey. But what are these things? And most of you probably have a basic understanding, or probably much more understanding than I do at a technical level. But in short, LLMs, they've been trained on just massive amounts of data, right? We know that. It's everything on the internet, potentially everything in the public domain. No one really knows for sure, but vast amounts of data. And some LLMs you've probably heard of are, Lambda from Google, Llama from Meta. Google has its chatbot Bard, and so on. And then GPTs are actually basically a subset of LLMs. They're a specific type of LLM developed by OpenAI. And what's special about them is something called the transformer. the transform was actually a concept brought about by Google Brain in 2017. And it was revolutionary because the whole idea is it can look at all of the words at the same time in a context rather than looking at them sequentially the way recurrent neural nets used to do. And that was just, it was improved speed and efficiency and pretty much revolutionary. And I have links to all of this stuff at the end. So there's a lot you could go into with learning how these things work. But at the core of it, it's predicting the next token in a string of tokens or the next word in a sentence at a very high level. And you can see just the vast amounts of data that it's been trained on, right? In a matter of a few years, GPT-3 went from 45 terabytes of text data to 1 petabyte and over 1 trillion parameters. It's just been changing at a mind-blowing pace. So I mentioned RAG, and the simplest way to think about this is you're a chef and you know all of your ingredients. You may have expertise in Italian cuisine, but you need to learn a recipe for a client tonight in Mediterranean cuisine. So you go out to a Mediterranean recipe book. You fetch that, you feed it to yourself, you read it, right? You insert the chip into your brain, whatever it is, and then you produce that Mediterranean meal. So it's a really, all my examples I think are RAG based, but it's a very good way to make the model smarter, especially when you need up-to-date information or just specific domain knowledge for whatever problem you're trying to solve. But why we're all here, why use Shiny, right? Number one, most of us are probably data scientists. It's what we know. We've been coding in R or Python. There is Python for Shiny. I've used it, but I'm still an R nerd at heart, just having been using it for so long. But we're enabling non-technical users to interface with and react to these highly complex models quickly. I think that's hugely valuable to make this accessible to everyone, not just like in the ChatGPT web UI. And then we're also, this whole concept of, I've been pushing it forever, rapid prototyping in Shiny is just unbelievably powerful. You can build things so quickly and iterate with your stakeholders and or clients and get feedback very quickly. And there's so many things in building data products that you just can never predict. So Shiny is just incredibly powerful. Lets us focus on what we're good at, and that is, analyzing data, but then also being able to build a product. So I'll go into some personal productivity examples. I use this all the time. I mean, it has been such a time saver for me. So in one of the examples you'll see, I was trying to figure out how to paste a bunch of links and article titles together. And as you probably all know, paste and then unordered lists and hrefs, and it's just a syntax nightmare, right? And I fussed with it for maybe 3 minutes, and I was like, screw this, like just put the code into ChatGPT, tell me what I'm doing wrong. And it worked. Like I was like, oh, this is great, right? I didn't have to like look at it with a fine tooth comb, even though I'm usually pretty good at debugging stuff like that. And then not only that, but it will explain it. So this is a great educational resource as well. It told me, hey, you had a underscore outside of your blank, for example, or you weren't closing this tag properly. And so it's just such a quick way, rather than like sifting through Stack Overflow or creating a reprex. We all know about reproducible examples, very time consuming to create sometimes. You can just get your answer right away and also have code explained to you. The last personal productivity example is in code translation. Now, this is another thing I use all the time. Again, as an R nerd, I just code, and I can code in R in my sleep. Python, I'm dangerous, but not like I am in R. So I already had an application built in Shiny, of course, in R. And this is what's called an appeter. So for any bioinformatics people out there, they're a collection of web-based kind of workflows, and they're available freely, and you can just kind of plug and play them into your apps. And this was super cool. I was like, I need this. I'm doing some drug enrichment analysis, which I'll talk about in a second, but I needed it in R and I wanted it quickly, and I just wanted to plop it into my code. So I said, hey, ChatGPT, transform this to R. And there was sometimes there's little hiccups, but for the most part, it gets you like 90% of the way there. And I think it's just like a really good time savings, even in just typing, honestly. Another example I used it for here was I needed to convert an Avro file, which is like a Parquet file, but row oriented. And I needed to convert it to a CSV. So I said, hey, ChatGPT, write me a Python script to convert this Avro file to CSV. But on my machine, it only worked on Python. It wrote it for Python 2.7. And you know how it is. I did not feel like messing with virtual environments and changing it and activating it. I said, oh, please just give me this in like Python version 3.11, right? That's what I have right now. I just need it quickly. And it did it and it worked. And again, I was just totally bought into this use case. So these are specific coding examples, but then I'm going to talk about kind of the bigger picture. And the first one is I'm going to go through 2 use cases. This is for a client called Sports Innovation Lab based out of Boston. And what they do is their whole goal is to acquire new fans for teams and brands and leagues. You can imagine like the WNBA is blowing up right now. They've been working for many years on trying to grow that league and visibility. So we've done some cool work with them. They want to engage the fan of the future, and they do this all with data. So they have data that looks like this. They have a bunch of credit and debit card transaction data with the merchants labeled as such, ASUS, AT&T, and this is on 44 million consumers in the US. This is one of their data sets. The team layered their IP onto this by manually categorizing all 6,000 merchants, right? Very time-consuming task, but very valuable. And you kind of do it one and done. Okay. But then, you could see, for example, they've got categories like active and athleisure. That would be, Adidas, Nike. But then they migrated to a new data source and had to redo all this work. And I was like, this is a perfect fit. We've got training data. We've got the categories. Why waste man hours doing this, right? So first thing I did was I went to the web app. Everyone's probably used this. This is openai.chat/ChatGPT or something like that. And I just put a couple merchants in there, just the name, nothing else. And ChatGPT has a built-in Bing search, so it will go out to Bing and try to fetch information. Again, RAG, right? Retrieval Augmented Generation. And I saw it. I was like, it does pretty good. This is likely news, print media. It even says when it's unsure, but it can guess it's jewelry because of the word bracelets and so on. But this doesn't scale easily in the web app. And I noticed it needed a little more information before because there's some company names that just aren't descriptive, right, about what the company does. So we leverage an API. And here's where I used Crunchbase. So in Python, not R, I fed the company name into Crunchbase. We did this for about 6,000 companies and said, give me back the company description. So Nike, they sell athletic shoes, for example, and, merchandise or jerseys. So then I would take that and the company name and feed that into now GPT-4 and ask it, given this list of 80 categories that we already have, categorize this company. And remember, this is a very good example, too, of garbage in, garbage out, because sometimes the descriptions were not accurate from Crunchbase. Like one of the examples was I gave it the Denver Broncos, and it gave me back the Denver Post. So, all of this is dependent on the quality of the data you provide it, as is any of our work. But what happened was, this is the application that I built for them. The categories now show up as they wanted, exactly as they wanted. They were very happy with this. I'll talk about the results in a minute and the comparison, but this is an example where they're looking at Boston Celtics fans and where they spend their money. We want to acquire more Boston Celtics fans. How do we do that? So we compare how Boston Celtics fans spend on casual dining compared to the entire general population, the United States, and found there's always going to be regional effects, but we found that 99 restaurants, they shop there quite frequently. This 110 grill. Okay, what else? Fitness. We can click fitness and get a drill down into the merchants, and it was Orange Theory Fitness and Boston Sports Club. So the team is doing this, very manually. And I just noticed they were just trying to find things on their own. And at the end of the day, they need to put together a targeted digital ad strategy to acquire more Celtics fans. or WNBA fans, whatever it is. So I had this is hot off the press like 2 days ago. It's not perfect yet, but I think you'll get the idea. You click this button, prepare a marketing strategy, because I've seen them do this over and over the past year or two. I've seen the end result. And Shiny pops up in this nice modal window. Key insights from user-provided shopping behaviors. It recommends things like develop partnerships with top visited merchants like 99 Restaurants, Orange Theory Fitness, and Boston Sports Club, right? Have a themed night dedicated to Boston Celtics fans. Now, this is all GPT generated, but I gave it the results first, the aggregated results that we were looking at one by one. So how does this work? I think this is really cool. This is kind of next step that we're taking it. We're just automating a lot of the manual work that's being done to distill a bunch of kind of data results into something actionable and usable. And here it is. Not complicated. Here's the R code. So we use the HTTR package. The most important thing is the system instructions. And I just made this up the other day. This can be improved, I'm sure, 10x. And I can also do some fine tuning, which I'll talk about. We haven't done any of that yet. So most importantly, you're telling it what to do, what you're looking for. You explain the variables that you're giving it, what they mean, and then design a digital targeted advertisement strategy to acquire more fans of the Boston Celtics. And limit the response to 500 words. This is to save us money on token usage, right? Because pricing is based on input and output. It doesn't always pay attention to this one, so it's kind of interesting. Still working on that. But if people have ideas, feel free to reach out to me after. So you want to always provide the system instructions first. This is your body of the parameters you're going to send. I did learn recently this matters, the order matters. And then the user data, which is just what you were just looking at. Remember the merchants and the percents and the indices. I actually provide it like this. And I actually just use as key values. I don't use JSON here because it actually saves tokens. You don't need all those braces. It just needs to be readable by GPT. And this I found was a very efficient way to do that. So then you send it and you get your answer. So this is, I think, going to be a very common use case in these types of applications. You've got a bunch of data, and you need to distill it down into a executive summary even. And you could even target it to the type of person you want to display the message to. And I'll show you an example of that in a minute. So overall, it worked really well for a quick one-off task. Those credits for OpenAI in total were maybe $300, and a few of human hours to validate. It was actually, they said it was better than an intern who had combined some coding and did manual Googling for like a week straight, right? So that's just time savings right there. The intern may have been better served just helping to validate the results, but we wanted to kind of do this experiment to compare them next to each other. And then we streamlined. We're doing tons of manual summarization in the past. So if there's kind of a cookie cutter product or deliverable you're trying to create, this is a very good fit. Give it the data in a structured way, give it very precise instructions, and let ChatGPT do the heavy lifting for you. So very good with summarization of language. The next, and I'll save time for questions at the end. Don't worry, I think we're pretty good on time. But the next case I wanted to talk through is this really cool AI-guided drug discovery. This is a company also based out of Boston called Archetype Therapeutics. And this was started by a few former bosses. I'll explain at a very high level what they do. But they built a drug discovery and repurposing platform. What does that mean? There's a TensorFlow model behind the scenes, but essentially they can screen billions of compounds per day, all in silico, and predict the clinical outcomes of each. So, for example, we have a lung cancer model, and we have the survival ratio. How long would patients survive on average given this drug? Which is huge because most of these companies are not tying drug simulation to a clinical outcome. They're doing something like what protein does it bind to, and so on. So this has very immediate clinical relevance. But how do we make sense of billions of drug results, right? And that number is growing because there's also ways that you can create new drugs. You can imitate a chemist and change the compound in a programmatic way. For example, adding or removing a hydroxyl group that can make maybe the binding activity better. So lots of data. Of course, we use Shiny. Now, this is there. We can get smart about scoring and filtering, but we weren't sure yet how to create that without at least visualizing the results. And I know, you probably all know, like, Shiny is just perfect for that. Like, I need to just look at my data. I need to interact with it. I can't make up an algorithm yet without seeing some of it. So what you're seeing here is I had to blur out the drug names, but the results and all the various statistical measures that we care about. This is a reactable. Thank you, Epsilon. I use reactable.extras frequently. And what you're seeing on the right is, like I said, that hazard ratio of death and the concentration of the drug. It's a dose-dependent response curve. You want to see, this is good, a low ratio of death at a low concentration. But what I noticed was my client kept, manually looking up, going to PubChem, going to PubMed. Oh, what is this drug target? What's the gene target? How does it work? And so they're going to PubMed and they're doing all this research kind of in their head and then coming up with conclusions about these patterns of what we're looking at. So instead, I wrote something using an appeter, which I showed you before. You can click, let's say, 10 drugs that you're interested in, and then run something called drug enrichment. And that was the appeter you saw. And I just said, convert this silly Python code to R. And we see, for example, these 3 drugs are enriched for targeting the gene CDK4. That was step 1. The next step is, well, go to PubMed, find me 5 abstracts talking about CDK4 in the context of, here it's sarcoma, and explain the mechanism of action of these drugs. I want to know, these drugs for this gene, what's happening? And this is also the coding example I showed you where I was trying to get the bulleted, links, and it was just giving me a headache and quickly fixed it for me. So it will summarize, okay, this first abstract discusses X, overall CDK4 is implicated in the progression, blah, 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 blah. Now, what's really cool here, I changed the prompt and said, explain this to a person that doesn't understand biology. And you can see below, it's really cool. It said, in short, CDK4 helps cancer cells multiply rapidly, and blocking it with specific drugs can slow down or stop the growth of certain sarcomas. Right away, I was like, wow, that's actually so much nicer to read. Even as a scientist, I used to read publications and can't they just use simpler words? But when you get used to it, you get used to it. But this is super powerful, in my opinion, making kind of the science more available to a wider audience. And I have to go to back in the day, which wasn't that far back, but if everyone remembers, tidy text, I'm sure we still all use it. There's still use cases for it, don't get me wrong, but back, you'd have to tokenize this yourself. You'd have to take all the text, you'd have to remove stop words like and, the, from, you'd have to figure out negating words, the order of the words in which they appear. You'd have to figure out sentiment. And what I find so fascinating about this technology, it's doing all of that for us. It's pretty mind-blowing. And I don't want to buy into the hype too much, but there are, I think, uses for this if you're using it in a responsible way. So benefits here, again, save time having to go out and manually search. You're just kind of automating this, like going to the library, pulling out 5 books. If you know what question you're trying to answer and you know what you're looking for, it is a very good fit to just say, summarize this for me because I want to know X. Now, this is not going to be the case everywhere, but again, if you have a very, I think, targeted question, it's very powerful. It also enables, non-biologists, for example, to understand this drug mechanism in the context of whatever disease you're talking about. Now, I want to transition to a personal story. My, unfortunately, very healthy 65-year-old mom passed from sarcoma in 2020, and in 9 months. And I sort of promised her, as a bioinformatics, person that I would do stuff, whether it's fundraising or charity or volunteering or research, to try to find a treatment for this awful disease. So while I was building this for the client, I said, I could build a tool in Shiny that could gather so much public data. My hypothesis is that there's just so much out there. Everything on PubMed. I know there's all the experimental data, all of the genetic annotation data, all of the databases that the NIH has put together, that so many great organizations have collected that they make freely available. So if we can distill text down into useful bits and summaries to make actionable decisions, I just thought there's got to be something here. So this is also very new, but I want to expand upon this. I'm pulling data from clinicaltrials.gov and doing the drug enrichment. And I want to understand things like what's working, what's not for sarcoma. And just doing some basic analysis in ChatGPT, which would have taken me hours upon hours with just plain old tidy text, very quickly, all of the reasons for failure of these studies is lack of patient enrollment because it's so rare. So that said, this is kind of my like AI for good plug. I'm just personally excited about the application of these tools and using them for good. As you can see, I build stuff for fun too. That's the best way to learn. But I want to give back and maybe open source this tool to small pharmas or any pharma working in rare disease, but especially sarcoma, because there hasn't been a treatment change in something like 30 years. It's still the same protocol. So if anyone has any ideas or wants to reach out or collaborate or knows someone that was affected or would be a right person to talk to, that's my kind of personal AI for good plug. So I'll summarize, and I think I breezed through a lot of this so I can spend a few more minutes here. But most importantly, providing additional information, that RAG concept. You're going to be using APIs. You're going to be bringing in internal documentation. These things aren't just like magic machines that answer any question. You need to give it the appropriate equipment. This is, a woman helping this robot, for example. All my images, by the way, in this are generated by AI. They're all generated by Midjourney in this presentation. So that is always going to produce, more accurate results. And the more specific you can get in the instructions, it's the same with machine learning. That you have to train the model. You have to tell it what to do. And I think there's always going to be some amount of human validation with these tools. We're far away, unless there's certain use cases where AI can completely do the thing. But I think we're far away from not having a human in the loop, because these things, which I'll talk about in a second, can be wrong and are wrong. Fine tuning is a really cool way to improve the results, which I haven't tried yet, but I'm about to on another project. At a very high level, fine tuning, you give it kind of your prompt and you give it the perfect response that you would want. And you give it as many of those as possible. And that will kind of just fine tune the model to get better and better at giving you the answers you want. So in that one I showed you, for example, for Sports Innovation Lab, we want to remove some of the more obvious results like Ticketmaster. Yes, sports fans go to Ticketmaster. We know that. We want it to be less generic. We don't want it to talk about mailer campaigns. So those are all things you can do and train these models to do to get better and better and better. But most importantly, just don't be afraid to just build and tinker and play with ChatGPT on the web. And you're not going to break stuff. And it's actually been very cost effective to use. I think I've spent no more than like $20 in the past few months. So I have ways to minimize those costs. It's like I said, not sending tons of text like the JSON. Using minimal key value pairs. Using models. Don't use models you don't need. If it's got 168,000 token context and you don't need that much, use a model that only needs 3,000 token context, for example. And like I said, the robots aren't taking over yet. AI cannot replace the ability to ask a good question. And I want everyone to think about for a second, what makes a good question? And I'll tell you, it's not just being detailed and concise. They prompt the person to do something. because I can give you trend charts and heat maps and beautiful Sankey diagrams all day. But if you're not doing anything with it, you might as well just frame it and put it up on your wall and check a box and say you did it, right? So most importantly, anytime you're doing this stuff, just constantly ask yourself, why am I doing this? Like, what am I going to do at the end of the day with this question? Why am I asking for a trend over time for sales in this region if I'm not going to do anything about it, for example? I know some of you are probably laughing because I'm sure you've gotten that. And then ethics and integrity, you could have a whole talk just on this. I know I summed up a lot of things here today, but biases are a major unaddressed problem. There are things they consider masculine or feminine or racially specific. And so you have to be very careful using these tools as well. Don't let it just blindly answer questions about, HR related who to hire or who not to hire, for example. Uh, Always check everything and kind of be up to date on what's going on with the biases in these tools. And again, they're not always correct. I have a link and at the end here that talks about these hallucinations that happen. They're called hallucinations literally. And sometimes the answer is just literally flat out wrong. And it's still a studied area of why it happens, but mainly, missing training data. Um, Maybe the prompt wasn't correct. There's lots of reasons why they happen, but that's why we always need to validate results and we need people with domain knowledge. So I rely on my clients frequently to validate what's coming out of these things. Same way we do with predictive models and machine learning models. We need the expert that has the domain uh, expertise to give us feedback and tell us whether our models are crazy or not. And then we can use that feedback to improve the model. And this also applies to code. Don't be afraid to use these tools to learn how to code, but don't just take the code and assume it works. We have to check. That can be a dangerous route, right? So what's next? A lot of stuff. This is very high level, but you're going to get more efficient. There's going to be more personalized interactions. I mean, that's the thing, right? Uh, Facebook and they all know stuff about us. It's going to get more and more personalized. What I'm hoping does not happen is that, the same way that there's paid advertisements that reach us, I hope the AI responses don't become, personalized, right? Google, Bing, going out and searching for you. We're hoping that these stay as unbiased as possible, but again, that's a huge problem. We're seeing a lot of domain specific models. So there's one, for example, called Biomed LLM. Is that the name? Yes, Biomed LM by Stanford. Now, let me go back to my, and that's trained just on, all the PubMed articles basically in existence. You're going to see things in law and education, and you're going to see in-house private LLMs because people don't want to send their data to OpenAI, even though they promise to not use it in their training and they promise to remove it from their servers after 30 days. People also don't always trust AWS and their firewall and security. So it's always a judgment call. But for good, that's the thing I'm really excited about. How can we use this technology to transform healthcare, access to government resources? And I just want you all thinking about the fun things you can now build, and don't buy into, the hype, but don't be too pessimistic either, because I guarantee you're missing out on time savings if you're coding, at least. I've also had it write blog posts based on my code. I'll just give it the code and have it summarized. And obviously you go back and edit, but I don't really use Stack Overflow anymore. It's been pretty great. But here's an example that I think is a great example of a useful chatbot. We all probably can't stand chatbots, like on Facebook and your customer service. You're like, oh, it's like the next generation of the phone tree, right? Give me a person. This is a chatbot that this woman created to help a person navigate getting family paid leave. So what's cool is if you live in New York, you can ask it questions like, what's the first step? How long do I have? How do I coordinate leave, right? What's the maximum amount? And this is so cool because it's obviously trained on the New York laws and regulations around paid leave. I would have loved a tool like this when my single mom was applying for the FAFSA for school loans. 20 years ago, I don't know. So just want you to start thinking and maybe get a little inspired by the things that are possible. Whoa, back to my slides. And a huge thank you. I have to thank these people. They've all provided me feedback and help on this presentation. They're all friends of mine. My wife, Stephanie, has been instrumental in helping me create this. And I have a lot of useful links here. We'll send these slides out. So I'm ready to take questions. I hope that wasn't too quick. Thank you for having me.
Great, lovely. Thank you for that, Tanya. We had quite a lot of questions on that one, so clearly it's stirred up a firestorm in the chat.
Oh, nice.
People very interested in this topic. I want to start with one, which is what context window were you using when you were sending it to the API? Because I know that with increased context window, I believe will increase the cost, and also if you're using GPT-4 instead of 3, then also that will increase the cost. So what model did you decide to choose?
For most of these, I am using, I'm trying to find the name, it is GPT-4 0125 preview. And
that's the 128K, isn't it?
what's that?
Is that the 128K context
Yes.
window?
Yeah, and I only see, again, you probably don't always need those. I switched to that one specifically because I was pulling in PubMed abstract data and I had so many tokens to feed it. So that was the reason why.
Yeah, lovely. Now, is it safe to be feeding data through the API or in the online interface? Is there any considerations that need to be made there?
Yeah, I mean, all your data, if you're using anything that uses OpenAI, is being sent to OpenAI. And they claim that they don't use it for training and they only keep it on their servers so that you can get better answers and they can identify abuse. But they claim to delete it after 30 days. So it is a consideration, and it's a big reason people are starting to try to spin up their own private LLMs, but they're just incredibly expensive to build and train.
So have you explored sort of hosting LLMs sort of inside of a Shiny app or anything like that?
You might be, well, Hugging Face is a good resource for that. Some of them allow you to embed, huggingface.co. It's a big kind of community collection of LLMs. What I've found, I haven't done it myself yet to put my own kind of LLM, but my experience so far is they're pretty large, and I haven't done it. So I'd be very curious if anyone has and how it works.
When you were in that first application, when you were getting it to categorize different things with different pieces of text with labels, did you provide it with what the categories were that it could select from?
Yes, and I noticed this is where the system and user comes into play. Sometimes it would make up its own category. So I had to remove the system instruction and say only select from this list, and I gave it the 75 categories, and then it listened. So yeah, you have to be like really specific in some cases.
And was it quite reliable in actually selecting from the list all the time?
Yeah, we didn't see one outside of the list after I made that change.
Oh, brilliant. Have you found any other sort of interesting ways to reduce token usage and reduce cost?
Um, yeah, I mean, other than trying to reduce just the amount of text you're giving it if you don't need to, you can use the older models that are much cheaper, like GPT-3 and 3.5. Supposedly, they're not as good at complex tasks, but if you don't really need the amount of tokens and you don't need to be doing multimodal stuff like giving it images and audio, and you can use those older models, probably no problem. Other than that, I haven't come across any other ways other than, you know, just try to be judicious about where you're using it, and if you're overusing it or repeating it, there may be some caching you could even do if the users, you're getting the same answer. Remember, there's going to be a little difference in the response every time, but if at the end you've got, well, GPT is pretty much saying this, maybe there's some creative caching you could do.
Awesome. I've noticed that now, I think as of about a week ago, the default model for the ChatGPT browser application is for GPT-4 is to use the 128K context window. And I'm curious, as of the release of that model, is there anything that you've noticed you can do with an increased context window that you would never have been able to do previously, sort of in addition to what you've done with the application?
Yeah, one of the things I did then the reason I needed the context window, I was trying to build my own SQL query generator from natural language. So providing a schema, providing a question, and then getting back a massive, or getting back all the SQL, that was just taking up a lot of tokens. So it was able to do that. I did exceed a token length when I was trying to use GPT 3.5 for that. So you'd be able to say, I have a bunch of sports data locally, and you'd be able to say, it's very similar to statmuse.com. You could say, how many yards did Tom Brady throw for in 2010? And it will basically, but I had to give it the schema, the table names, the columns, as much as I could, and it just massively exceeded the. But now there's tools that do that. There's a lot of SQL, natural languages SQL generators that I'm still playing around with. Would love to know who's had the best experience with which ones. I'm looking at Vanna.ai right now. I think that's a really powerful but dangerous tool as well, because the SQL, we're not going to know if it's right unless we see it and we have a SQL analyst basically validate it.
Yeah, I can imagine all sorts of things going wrong there. But,
Yeah.
I'm curious. You talked about how you could save sort of the time. You'd have one individual sort of performing this manual task for like a week, and you could save that time. I think it was about $300 you said in the end. Now, how do you sort of verify and evaluate the quality of the results and the generated text to ensure that it was going to be the same as if the human had done it manually?
That was the manual human validation part. Basically, we had my client who was working on the project, knows the categories and data inside and out, and she would basically, I gave her like 10 results from each category, and then she went through as many as she could and just said, yeah, this looks good. It kind of becomes like an 80-20 rule. Like this looks good enough, and if we find one that's wrong while we're building out these tools, we'll fix it. So it's very much, that's the part that no one wants to talk about, that there is still this manual process of validating and making sure the results look good. But like I said, there's this fine tuning, which I haven't dove into yet, but apparently that can reduce those sort of inaccuracies pretty well.
Yeah. One thing I've spotted when I'm using the online tool is that I sort of have the choice between two things. I can either go and try and do a task manually, and that might take some time, but I'll sort of know I'm getting there because I'll be making progress. Or I can go and try and write a prompt that will do the same thing, but it will take me quite a long time to get the prompt perfect, and then I might have just wasted a whole bunch of time and not actually achieved anything, because the model can't do it. So I'm curious, how, in your opinion, how would you say to yourself, okay, I'm not really getting anywhere with the model. Maybe I should go and try and do this the old-fashioned way and use my fingers to type out code. At what point do you say, all right, the model is not going to get me anywhere here?
Yeah, that's a good question. I think it goes back to literally the same thing we used to ask ourselves when we would say, is this a one-off thing I can just do in Excel? Don't need R for, which I will say is very rare for me. I rarely use Excel, but there's times that it's just quicker to do it in Excel and not code up an entire solution. It's kind of the same thought process. It's like, is it going to take me longer to perfect this prompt and get this data than it is to just maybe write my own, for example, right now we're working with a client that wants to use it to collect data on small businesses. And a lot of them there just is no results in Google. There's nothing there. It may make sense to just write their own scrapers because it's just not doing a good job, and you'd have to do so much tweaking and fine tuning to get it to work well. That sometimes, yeah, it's really just how much time will it take versus can this thing save me some typing time?
Yeah. I'm really curious. As we sort of come to the end of this, is there any sort of other projects that you were engaged in? Whether in your personal sort of addiction to this sort of stuff, or whether it be professional. Is there any other interesting use cases you're investigating at the moment?
I love that you call it addiction because it really has been since it came out.
Yeah, I think my balance on the API has gone down rapidly.
What's that? The
My
cost?
balance on the API has just gone to
Oh,
zero every day, honestly.
yeah. I mean, between the natural language stuff, I think I'm doing a lot. I don't have much time lately for the sports stuff, but I still want to explore that. I still think that there's I'm talked about that open source tool for clinicaltrials.gov. I think I know there's work being done on it, but there's ways to rapidly accelerate the patient inclusion criteria process of matching patients to clinical trials, because it's just PDFs
Wow.
and PDFs of free text. And if you could help, these people are reading it manually. They're looking through the patient record. Obviously, there's a lot of health concerns around HIPAA and all that. But I think that's going to be a huge use case for this. Just accelerate that whole manual process of can this patient be included in this trial or not based on their age or past medications or whatever it is.
Amazing. Well, lovely. That's sort of, there we go, just on time. So, Tanya, thank you very much for speaking to us today. It's very, very interesting, honestly. Thank you.
Thank you. I love talking about this stuff. As you could tell, I could blab on about it for hours. So thank you for having me.